Okay, if you've been enjoying the short videos lately, settle down. This one's a little bit longer. My apologies here. Students will locate the focus and directrix of a parabola. All right, we've already found the vertex. And in fact, the matter is we'll have to find it again today when we do everything else. And we'll also be finding the axis of symmetry. But the key here is the focus and the directrix. Now again, just a quick reminder, the story about the dog. The path that the dog makes as it runs around is the actual parabola itself. Since the dog never knows when the train might show up or when the dog food might show up, it wants to be equidistant between the house and the train tracks. The house, of course, is where the focus is located. The train tracks are the directrix. And the axis of symmetry is a vertical line that goes through both the focus and the vertex. And when you see the dog at rest here, that of course is the vertex. Now, we've been kind of playing fast and loose with the standard form. That is the standard form of a quadratic equation, to have the ax squared plus bx plus c. But if we actually want the standard form of a vertex, it's a little bit different, right? So we really should have been calling that the quadratic form. For the standard form, it's x minus h quantity squared equals 4 times p times y minus k. And you're like, oh, interesting, the letter p shows up. What's going on with this thing? Well, the vertex, h comma k. Notice I have to do the opposite sign for each because each of them was inside a set of parentheses. For the focus, the x-coordinate is still h, but the y-coordinate is k plus p. For the directrix, notice this is not a point, so I don't have an ordered pair. The directrix is a line, so I have the equation of a line. Since it is a horizontal line, y equals k minus p, right? Where k and p are both constants, right? There's no variable because the slope has to be 0. And then for the axis of symmetry, well, it's got to be a vertical line that goes through both the focus and the vertex. So the equation of the vertical line has to be x equals h. Okay, so let's see if we can figure one of these out. So here's an equation, standard form for a parabola. X minus y quantity squared equals 12 times y minus 2. Can I find everything I need? Well, if you're wondering, well, what on earth is that mystery number p? Well, from the formula, I know 4 times p has to be the coefficient. For the question we're doing, p is 12. 12 is equal to that 4p. So p has to be 3, right? 4 times 3 makes 12. So when I see that 12 in the equation I'm working on, I know that 12 has to be equal to 4 times p. I say, okay, if I divide both sides by 4, I can figure out that p has to be 3. So the vertex, I can read it right from the equation, 7, 2. Focus, again, this is a point, but I have to move p units from k. So I have to move 3 units up from that 2. 2 plus 3 gets me a 5. Directrix, again, this is a line. And I need to be 3 units, but in the opposite direction. So instead of 2 plus 3 making that 5, 2 minus 3 will get me a -1. Axis of symmetry, well, it looks like the vertex and the focus both have x as 7. So the axis of symmetry, x equals 7. So if I want to graph this, I can put a point at 7, 2, because that is the vertex. I could put a point at 7, 5, because that is the focus. I can graph a horizontal line for the directrix. And I can plot a vertical line for the axis of symmetry. Now, if I want to just try to draw the parabola freehand, I got to remember that as that dog runs around, it wants to be the same distance from the directrix as the focus. So I can try draw a parabola. And if you're like, well, did I do very well? Well, let's pick a point at random. Not really random. All right, and say, hey, is that point the same distance from the focus as it is the directrix? Well, it looks like it's exactly 6 units from the focus. It looks like it is exactly 6 units from the directrix. So yeah, that point's been pretty good, right? Notice the vertex is 3 units below the focus and 3 units above the directrix, so the vertex is in the right place. And if I try to draw that parabola, that's what I want to kind of do. So it's kind of like if you think about like a satellite dish with the antenna in it, right? The tip of the antenna is where the focus is located. The center of the bottom of the satellite dish would be the vertex. And of course, if I just want my actual graph of the parabola, that's what it would look like if I get some of that extra stuff away, right? I've got the vertex, the focus, the directrix, axis of symmetry plotted, and there is my parabola. All right, so it's time to practice. Oh, the bovinity as the dirigible comes down in flames, the Hindenburger.